Right now, or maybe this coming weekend, you might find yourself sitting on a park bench. You have a little time to kill, no pressing deadlines, no urgent emails, just you, a crisp breeze, and a paper bag of leftover bread or some fries. You toss a piece onto the grass. A crow lands. You toss another piece a few feet away. A second crow lands. And then, just to see what happens, you toss 3 pieces in a little pile to the left and 2 pieces to the right. Look at what happens next. The first crow does not hesitate. It hops straight to the pile of 3. And you smile, right? You think, well, obviously, the bird is hungry. It wants the bigger pile. It is a simple biological instinct. More food is better than less food. It is just volume, just a visual estimate of mass. But here is a question almost nobody actually asks, and it is a question that, once you really let it inside your head, changes the way you look at every single animal you will ever encounter. When that crow looks at the pile of 3 pieces of bread, does it just see a slightly larger blob of food, or does it see the number 3? Not as in, does it know the human word for it? Obviously, it does not speak English. We are not talking about human language. We are talking about the concept itself. The abstract, invisible, purely logical concept of 3. Is there a spark of mathematical comprehension inside that tiny feathered head? Does it know that 3 is exactly 1 more than 2 and exactly 1 less than 4? If you had asked this question 100 years ago, or even 50 years ago, mainstream science would have laughed you right out of the room. The absolute consensus was that animals live in a blurry, immediate present, driven entirely by instinct, smell, and reflex. We thought they just moved toward whatever smelled like the biggest dinner. Mathematics, we told ourselves, is the ultimate crown jewel of human intelligence. It is the thing that built the pyramids, launched satellites into orbit, and calculated mortgages. It is ours. We are the rational ones. They are the beasts. But what if we are wrong? What if we are spectacularly, embarrassingly wrong? What if the universe of logic and numbers is not a private club for humans, but an open language that the entire natural world has been speaking for hundreds of millions of years, right under our noses? What if the dog lying on your couch right now, or the fish swimming in your aquarium, or the bee buzzing around your window, holds a piece of the exact same mathematical architecture that Albert Einstein used? And the stakes here are massive. Because if we are the only ones who can count, then we are completely alone in our understanding of reality. We are sitting on an isolated island of logic in a chaotic, unthinking world. But if they can count too, if someone else is home, then the world is infinitely wider, infinitely older, and far more connected than we ever dared to imagine. So, buckle up. This is the rabbit hole we are going down today. And the evidence for this genuinely melts your brain. Let us start at the very beginning. What does it even mean to know you are looking at a number rather than just a pile of stuff? Let us start with the most obvious thing. The creatures we live with every day. Your dog. If you own a dog, you already know they have a suspicious ability to know when they are being cheated. If you usually give them 2 treats after a walk, and today you only give them 1, they will sit there, staring a hole through your soul, waiting for the second one. They know something is missing, and you are about to say, come on, that is just memory and smell. The dog expects a certain routine, and its nose tells it that there is more food in your pocket. Okay, that is exactly what scientists thought too. To prove it, they set up a simple experiment. You put a dog in a room, you show them a screen, you drop 3 pieces of cheese behind the screen, one by one. The dog watches. Then, secretly, you remove 1 piece through a trapdoor. You lift the screen. There are only 2 pieces left. What does the dog do? It stares. It stares significantly longer at the 2 pieces than it would if all 3 were still there. In the world of animal psychology, staring longer means surprise. It means expectation has been violated. The dog's brain is saying, wait a minute, 1 + 1 + 1 is 3. I am looking at 2. The math is not mathing. But still, skeptics argued, maybe it is just about total volume. Maybe the dog just expects a certain mass of cheese. So, researchers went a step further, and to really get to the bottom of it, they did not just look at dogs, they looked at their wild ancestors. At the Wolf Science Center in Vienna, Austria, researchers run by Friederike Ranger decided to test wolves against domesticated dogs. They took opaque tubes where you absolutely cannot see or smell the exact volume of what is inside. They dropped pieces of meat into 2 different tubes, say 3 pieces in one and 4 pieces in the other. The wolves watched the pieces drop. 1, 2, 3, 4. Then they let the wolves choose. The wolves almost always chose the tube with 4, even when the researchers controlled for the time it took to drop them, even when they made the 3 pieces larger so the total volume of meat was exactly the same. The wolves did not care about the volume. They cared about the exact quantity of discrete items. They were tracking the number. And the funny thing? The domesticated dogs actually performed worse on this test than the wolves. Why? Because over 30,000 years of living with us, dogs have learned that if they just look cute and wait, the human will eventually just give them all the food anyway. They lost the edge. But the wolf in the wild? A wolf needs to know exactly how many elk are in a herd and exactly how many wolves are in its pack. If a pack of 4 wolves attacks a herd of 5 elk, the math might work. If a pack of 4 attacks a herd of 20, someone is going to die. In the wild, mathematics is not a school subject. Mathematics is survival. But here is where the story takes a sharp turn. Because it is one thing for a mammal, a highly social predator like a wolf, to track quantities. We are closely related. We share a lot of brain structure. Let me throw you something even wilder. Let us leave the mammals completely. Let us talk about birds. Specifically, the very crow you were feeding in the park. Birds and humans have not shared a common evolutionary ancestor for over 300 million years. Our brains are built entirely differently. We have a complex cerebral cortex, the wrinkly outer layer where we do all our deep thinking. Birds do not have that. Their brains are smooth, structured more like a cluster of grapes. For a long time, we literally used the phrase bird brain as an insult. Well, thanks, early anatomists. You could not have been more wrong. In 2024, at the University of Tübingen in Germany, a neurobiologist named Andreas Nieder and his team conducted an experiment with carrion crows that genuinely shook the scientific community. They trained crows to look at a screen. On the screen, a number would flash. For example, the Arabic numeral 3, or 3 dots. The researchers wanted to see if the crows could not just recognize the number, but actually produce a corresponding number of sounds. Could they count out loud? Picture this setup. The crow is sitting there. No alarm clock, no mortgage, no Sunday night existential dread. Just a bird in a room. The number 3 flashes on the screen. The crow pauses, looks at the screen, and then opens its beak. Caw, 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 3 times. Then it pecks an enter key on a touchscreen to signal, I am done. The researchers tried it with 1, 2, 3, and 4. The crows adjusted their vocalizations perfectly. But here is the part that breaks your brain. By analyzing the audio and the brainwaves of the crows, the scientists realized the birds were not just reacting to each caw as they went along. They were not just saying one and then deciding if they should say another. Before the crow even opened its beak for the first time, its brain had already planned the entire sequence. It knew it was going to caw 3 times before it made a single sound. It held the abstract concept of 3 in its mind, translated it into a plan for physical action, and executed it. This is exactly what a human toddler does when you ask them to count their blocks. It is symbolic representation. The crow is not looking at 3 pieces of food. It is looking at a symbol, understanding the abstract quantity that symbol represents, and communicating it back. Yes, exactly that. A bird, whose brain is the size of a walnut, is doing symbolic mathematics. And you might say, well, crows are famously smart. They use tools. They remember human faces. They hold grudges. Maybe corvids are just the exceptions. Maybe they are the feathered geniuses of the animal kingdom. Okay, that is settled. Now forget everything I just said. Let us go deeper. Let us go somewhere where the brain is not the size of a walnut, but the size of a grain of sand. Let us talk about the concept of 0. Take that in for a moment. 0. 0 is not just another number. 0 is a massive, towering philosophical achievement. For most of human history, 0 did not exist. The ancient Greeks, for all their brilliant geometry, did not really have a number for 0. The Romans built aqueducts and an entire empire, And their numerical system, Roman numerals, has no zero. You cannot write 0 in Roman numerals. It was not until ancient mathematicians in India fully conceptualized 0 as a number with its own value, a placeholder that represents nothingness, that modern mathematics could even begin. Understanding 0 requires a brain to look at the absence of something and realize that the absence is itself a thing. It is a category of quantity. Nothing is a number. It is a concept so difficult that human children struggle to grasp it until they are around 4 years old. Now, picture a honeybee. A honeybee has about 1 million neurons in its brain. You have 86 billion. A honeybee's brain is literally the size of a sesame seed. A few years ago at RMIT University in Melbourne, Australia, researchers led by Scarlett Howard and Aurore Avages-Weber asked a question that sounded completely absurd. Can a bee understand 0? They built a Y-shaped maze. At the end of the maze, there were 2 platforms. On the walls behind the platforms were white cards with black shapes printed on them: squares, triangles, circles. First, they trained the bees to understand the concept of less. If a bee flew to the platform with fewer shapes on the card, say 2 shapes instead of 5, it got a drop of sweet sugar water. If it flew to the platform with more shapes, it got a drop of bitter quinine. Very quickly, the bees learned the rule. Always go to the smaller number. 3 is better than 4. 2 is better than 3. 1 is better than 2. Then came the ultimate test. The researchers put up 2 new cards. One card had a single shape on it, the number 1. The other card was completely blank. Nothing. 0. The bees had never been trained on a blank card. They had never received a reward for nothing. From a purely biological standpoint, a blank card is just a wall. It is an absence of information. The researchers opened the gates. The bees flew into the maze. They hovered in front of the cards. And then, consistently, deliberately, the bees chose the blank card. Let that land. They understood that nothing is a quantitative value that is less than 1. They placed 0 at the bottom of a numerical continuum. A creature with a brain the size of a sesame seed, an insect that lives for about 40 days, inherently grasps a mathematical and philosophical concept that baffled human civilizations for thousands of years. And honestly, this one gets me every single time. It feels both creepy and incredibly beautiful. We look at a bee and we just see a little biological robot collecting pollen. But inside that microscopic architecture, there is an entire universe of logic operating in the dark. But if you think that is strange, wait. Because we are getting closer to answering our main question, and it is about to get humbling. Because it is one thing to say animals can count, it is another thing entirely to say they might be fundamentally better at it than we are. Let us travel to Kyoto University, Japan. The year is 2007. A primatologist named Tetsuro Matsuzawa is running an experiment with a young chimpanzee named Ayumu. Matsuzawa wants to test numerical working memory. How fast can a brain process a sequence of numbers? The setup is a touchscreen. On the screen, the numbers 1 through 9 appear in random positions. The subject has to tap the number 1. The exact millisecond they tap the number 1, the remaining 8 numbers are instantly covered by blank white squares. The subject then has to tap the blank squares in the correct numerical order, from 2 to 9, relying entirely on the memory of where those numbers were just a fraction of a second ago. When human college students do this, they struggle. If you give them a few seconds to stare at the screen and memorize the layout, they do okay. But if you flash the numbers for just 210 milliseconds, literally the duration of a human eye blink, the human students fail miserably. They guess. They get it right maybe 40% of the time. Then it is Ayumu's turn. Ayumu walks up to the screen. He does not even seem to be paying full attention. The numbers flash for 210 milliseconds. In a blur of motion, Ayumu's fingers fly across the screen, tapping the blank squares in perfect sequence. 2, 3, 4, 5, 6, 7, 8, 9. Correct. He does it again. Correct. He does it over and over with 80% accuracy. He is processing the numerical sequence and mapping it spatially faster than the human brain can even register the visual input. He is not just as good as us, he is vastly, undeniably superior. And you are probably thinking, wait, but why? If we are the hyper-intelligent apex species, why does a chimpanzee have a better mathematical working memory than a university student? The honest answer is, we traded it away. Scientists call it the cognitive trade-off hypothesis. Millions of years ago, our ancestors had that exact same lightning-fast photographic numerical memory. It is incredibly useful in the wild. If you are swinging through the canopy, you need to glance at a tree for a fraction of a second and instantly know exactly how many ripe fruits are on the branches and exactly where they are. But as human evolution split off, our brains had to make room for something else. Language. Complex, abstract, metaphorical language. The ability to tell stories. The ability to say, "What if?" Our brains literally rewired themselves, shrinking the hardware dedicated to instant numerical memory to expand the hardware for speech and long-term planning. We lost the raw, immediate mathematical reflex of the forest so that we could gain the ability to talk about the forest. Ayumu did not lose it. He still has the ancient hardware running at full capacity. And this is where the story stops being just a fascinating collection of trivia. This is where we have to look at the other side of the coin, because here is the part we do not like to talk about. Here is the part that actually hurts. For centuries, humanity desperately needed a reason to put ourselves on a pedestal above the rest of the natural world. We needed a philosophical excuse to treat the Earth as a resource rather than a community, and the excuse we chose was logic. We told ourselves that we are the only creatures capable of reason, capable of abstraction, capable of mathematics. In the 17th century, the great philosopher René Descartes famously argued that animals are completely mindless. He called them bêtes machines, animal machines. He claimed they do not feel, they do not think, they do not suffer. If a dog cries out when it is struck, Descartes said, it is just the mechanical sound of gears grinding, like a clock chiming the hour. There is nobody home. And that, in my view, is one of the most epically tragic and violently wrong takes in the history of human thought. Because we took that philosophy and we built an entire world on top of it. Right now, as you watch this, there are roughly 90 billion land animals being raised and slaughtered every single year in industrial farming. 90 billion. And among them are millions of pigs. Why do I mention pigs? Because at Purdue University, researchers put pigs in front of computer monitors and taught them how to play a video game using a joystick they moved with their snouts. The pigs understood that the movement of the joystick controlled the cursor on the screen. They understood the objective. They understood the scoring. Pigs are highly numerate. They understand quantities. They hold memories. They have complex social structures. And we put them in concrete pens so small they cannot even turn around for their entire lives. The very barrier we erected, the idea that they do not understand, they do not have logic, was a lie. The creatures we put into cages, the creatures we use for testing, the creatures whose habitats we bulldoze without a second thought, are exactly the ones who can count their losses. They remember, they track, they know. We tested animals for decades using yardsticks built for human hands and human eyes. We gave them math tests that required them to speak English, or use tools, or behave like human children. And when they failed our deeply biased tests, we proudly declared them stupid. We judged the fish by its ability to climb a tree. But the moment we stepped back, the moment we actually designed tests that spoke their language, a touchscreen for a chimp, a maze for a bee, a trapdoor for a wolf, the illusion shattered. The honest truth is that our blindness was never about their lack of intelligence. It was about our lack of empathy. We did not want them to be smart, because if they are smart, then what we do to them is an absolute tragedy. Sit with that for a second. We share this planet with mathematicians that have wings, with statisticians that have fins, with logicians that have fur. The one who feels, the one who calculates, the one who understands, that is exactly the one suffering at our hands. But I do not want to leave you at the bottom of that dark well, because while the realization carries a heavy ethical weight, it also carries something else, something profoundly beautiful. It forces us to completely reassemble our picture of what mathematics even is. When you were in school, struggling with algebra or geometry, It probably felt like math was an artificial torture device invented by a grumpy guy in ancient Greece. We tend to think of math like we think of chess or the English language, as a game humans made up with rules we invented. But the crow, the bee, and the wolf prove that this is not true. We did not invent mathematics, we discovered it. Math is the native source code of the universe. It is the invisible scaffolding of reality. The fact that 2 + 2 = 4 is true on Earth, it is true in the center of the sun, and it is true in a galaxy 10 billion light-years away. And the most astonishing thing is that biology, through millions of independent evolutionary paths, kept bumping into that same universal truth. The bee's brain and the human's brain took completely different roads over hundreds of millions of years. But when both brains needed to solve the problem of survival, they both tuned into the exact same frequency. They both discovered zero. They both discovered quantity. We are not sitting on an isolated island of logic. We are surrounded by a chorus of minds, all reading the same universal language, just in different dialects. We don't exactly know what it feels like to be a bee processing the concept of nothingness. Science can describe the mechanism, but it cannot crawl inside the experience itself. Maybe we will never know this, but we know they are doing it. We know the lights are on. And doesn't that change everything? Doesn't that make the world feel a little less lonely? We spent the last century launching radio satellites into deep space, hoping to hear a signal of mathematical intelligence from alien worlds, desperate for proof that we are not the only rational beings in the void. Meanwhile, the aliens have been here the whole time. They are sitting on the park bench with you. They are buzzing in the clover. They are sleeping at the foot of your bed. So let us go back to the very beginning. You are sitting on that park bench, the crisp air, the paper bag of bread. You toss 3 pieces to the left. You toss 2 pieces to the right. The crow lands. It looks at the piles. It is the exact same scene, the same bird, the same ordinary afternoon, but now you know what is happening behind those black eyes. It is not just a hungry animal reacting to a stimulus. It is a mind making a calculation. It is a creature holding an abstract concept of reality, navigating the exact same logical universe that you are. You look at the crow. The crow looks at the 3 pieces of bread, and for a brief, invisible moment, the two of you are connected by the oldest language in existence. We thought we invented mathematics to count our wealth, but nature invented it so we could all read the same universe. If you have a dog or a cat or a bird, go look at them right now. Give them a treat, or maybe try the disappearing trick, and tell me in the comments, do you see the calculation happening in their eyes? Have you ever caught them counting? I read every single one of these stories, and if you want to keep exploring the strange, beautiful abyss hiding behind the ordinary world, join us. Hit subscribe and let's keep walking down these rabbit holes together. See you in the next one.